uh, overall gain with feedback, and we discuss the negative
Sir, have you
in
started?
different.
Sir,
Yes.
can you please switch off your video because I think there is a bandwidth issue. Your audio is not clear.
Okay. 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 That I am doing. Just let me. Okay. Now, am I audible clearly? And also, my screen is visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, so what we have seen in the last class that last one means we are discussing about the feedback, and we have seen that already you know now that feedback, negative feedback reduces the gain, but increases the stability, and also there is some other several advantages of negative feedback, such as it increases the bandwidth, it increases stability, it reduces the noise factor, and nonlinear distortion. The positive feedback, though it increases the gain, but it increases the instability. And the positive feedback is required to get the oscillator or to design oscillator or getting some oscillation. So that I will discuss in brief today. Now, how negative feedback is applied in transistor circuit or in any discrete component. Now, let us discuss today so that you can have some idea practically that how the feedback topologies are used in the circuit and how the feedback uh, used in biasing to increase the stability uh, in transistor circuit. Already you know about thermal runaway. Have you heard about the term thermal runaway?
No, sir.
In transistor?
So,
Okay.
Yes, sir.
Uh,
Thermal running.
no, sir.
yeah, okay, okay. Let me explain you in this circuit first. What is this circuit in the diagram?
Sir, voltage divided
Common
by.
Yes, voltage divider bias, this R1, R2, R1 and R2, these two divide, this is here the VCC, if you consider it is VCC applied, and this VT is used as the voltage divider, R3 is used another to increase the stability. Now these three, combination of these three, the weighted voltage is applied to the input. Here in the emitter, it is a common emitter amplifier. The output is taken from the collector, right? This is the output voltage is measured from the collector terminal to with respect to ground. The load resistor is connected across the collector to across the collector. This is the load resistor, right? Now here there is no feedback resistor is connected. For amplifier, transistor amplifier, what we know? We know that the input and output has a phase shift of 180 degree. So that means with respect to input, whatever the voltage, if you increase a positive, then it would be negative. That if you increase the voltage, the output voltage will decrease. So if you see the waveform, then from that it will be clear to you. So for a common emitter amplifier, if we apply the input voltage as shown here in this diagram, this diagram is taken from internet. It is also available. The link will be shared with you. You can go through that for better understanding. Okay. So this is what if you give the input signal waveform like this, a sinusoidal signal waveform, and the output is taken from this collector, and if we see it is the just amplified version of the input but with mirror image of that. And this mirror image of the input waveform gives the 180 degree phase shift. Okay, that indicates that the input is increased over time at any point of time, the output is decreasing. So what does it indicate? The input output has a 180 degree phase shift, and once you increase the input voltage, the output voltage will decrease. Now, in some way, this indicates that if in some by some means the output is connected to the output is connected to the input for feedback purpose, then that will give the negative feedback. Why? But as you can see, the overall effect, one is increasing, another is decreasing. That means the overall effect, it will decrease the input voltage. So that is what the common basic things. Now how it is applied here in a practical circuit that you can see here. In this bias circuit, you can see this resistor, feedback resistor, R feedback is connected with the previous circuit diagram. Okay. So when this feedback resistor is connected, the output voltage, this node is connected from this output terminal. That means the output voltage is coming. Whatever the voltage will be appear or the current, that is proportional to the output voltage. Okay, so that means a part of this, whatever the input signal is coming, that is proportional to the output voltage, voltage signal. So that is from its, you can see as the voltage sample. What I told you about the topology, the voltage, what we are taking the sample signal from the output and how it is connecting to the input. Based on that, the voltage topologies are divided. So if the sample is output voltage, so it is a voltage. Now, if we see here at the input it is connected in series or shunt. How will you justify? So now you have to see whether the current is taking another path or not. If you see in the input current without this feedback resistor, the total whatever the input current that is applied to here to the base. Now with this resistor connected to this, now this current is taking two paths, or it is applied to the node here in the input. So whenever the current is taking two paths, what does it indicate?
Voltage divider. Voltage divider.
Shunt matlab it is connected in parallel.
Yes, that means it is parallel. So whenever say try to understand the series and shunt configuration. So if you consider a shunt configuration, that is parallel configuration, that means it indicates that it is taking two paths from a common node. So whenever such thing will happen, that is what the current is taking divided in two paths here. From whenever there is multiple branch from a common node, so from that is the current will be taking the multiple branches, divided into multiple branches. So it is what the current. Now the current, so voltage shunt. This is what the feedback topology is here. And again, as I told you, the output voltage is 180 degree phase shift with respect to the input voltage. So whenever it will be applied to the input in overall, now it will decrease the overall input voltage, and the effective voltage will be the weighted sum of all these R1, R2, R3 and this feedback. Okay. So this is what one circuit, transistor circuit, what indicates the feedback amplifier. Okay, so this is using voltage divider. Now without using voltage divider, this is the circuit configuration also that indicates a voltage shunt feedback. The same thing, just the feedback resistor is connected. This type of biasing is known as the collector to base bias. Hopefully it is all this is taught in your class. So this is what the collector to base bias. This resistor is connected from the collector to the base. That's why this type of biasing is known as the collector to base bias. Another amplifier. So if you consider the emitter, if you consider a common collector configuration. In common collector configuration, where the load resistance is connected, can you tell?
Emitter side.
Emitter side. Good. So can you identify this? Which type of configuration is it? Common emitter, common base, or common collector?
Sir,
You
common
Common emitter. Common collector.
Common emitter or common collector? You take.
The common
See,
emitter, because emitter is connected to the
look at
zero
this.
voltage.
Try to understand the difference between this circuit here.
Oh, sir,
Here,
common
where the load resistance is connected. For this case,
Collector side.
what
Collector.
type of configuration is this?
Collector.
Common emitter.
This is.
common emitter, sir.
This is common emitter.
This is common emitter, okay? Because emitter is grounded, right? Emitter is grounded,
Yes,
the
sir.
load resistance is connected in the collector. So it's a common emitter configuration. Now here in this circuit diagram, look at this here, the emitter is grounded through a load resistance. Actually here, the load resistance is connected in the emitter, and this collector, whenever you will apply AC, just if you ground is nothing but a common point with respect to which we measure the voltage. So that's why whatever it, there's the collector is connected here to the directly to the VCC, and it just if we take the reference voltage with respect to this point, as the load is not connected here, and we are taking the output voltage from here, so it's a common collector configuration. So remember, okay? So whenever the voltage will be taken from the emitter terminal, then it is a common collector configuration. If the voltage is taken from this collector terminal by connecting a load resistance here, then it is a common collector configuration. Okay, anyway, it is a common, sorry, for this case, it will be a common emitter configuration. For this case, where if we take the voltage from collector terminal, then it is common emitter configuration, and this is common collector configuration. Anyway, we are taking
Sir,
the voltage from
question,
here.
sir.
Huh?
Sir, in this diagram, the initial diagram, the emitter is both connected to the output and the input. So will it not be common emitter? Means why is it common collector then?
For common emitter configuration, this is grounded. Here the load resistance is connected. This is VCC is connected here. VCC, right?
Yes, sir.
আমি ক্লাসে আছি। Okay. So this is what now here what we are using here through resistor, base resistor, the voltage is applied. Right? Now it is grounded. Is it clear? Try to understand the difference here. This is the what? The load resistance here. We are taking from collector and the voltage is measured from here. This is what in this configuration the emitter is grounded. Okay. Now in common collector configuration, what is the diagram? Common collector configuration, the diagram, if I draw it in this way, what as per you, the diagram should be like this in common collector. It should be grounded. Here the resistor would be connected. Here the power supply, right? Here the resistor, and then the corresponding now here the corresponding uh, the circuit configuration will be like this. Is it clear? Now you tell me this configuration is which configuration? This circuit diagram. Do it fast.
Show that grounded, where it is grounded or where it is collecting.
Which
Common
one?
collector.
It is
Common emitter.
It's a common collector.
The
Common
common collector.
common collector, sir.
so who are saying common emitter and this they have not understood it. So, just a minute. Sorry. And now you understood it. It is common collector or common emitter. This is this circuit.
So common collector, the last one.
Common collector.
This one is
Yes,
common
sir, common
collector. This
collector.
one is common emitter, right?
Sir, the slides is not visible because the MS Team page is on
Yes,
the
yes, yes,
slides.
yes, yes. Just a minute. Now is it visible?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Now you tell me. This is what? This is a common collector and this is common emitter. Now is it clear?
Yes, sir.
Now
Yes.
you tell me what is
Yes,
the
sir.
difference between these two? What is the difference with this and this? What is the difference with respect to this and this circuit?
Sir, the load
Sir,
resistance on the emitter
emitter is
side
So
and
the position of the common
one
Sir,
more.
emitter
here
is
input
Huh?
is VBC. Input
What?
voltage is connected in different side on different side.
Not just it is if you reverse it, it is rotated. If you just flip it vertically, then the circuit
yes,
configuration is same. It's not that.
yes, sir. But I mean,
Sir, but one
application
thing,
becomes
sir, it's not same. Sir, the collector is grounded in the first diagram, the one which you have drawn with red. And here, sir, the collector is having a potential that is VCC in
That
the this.
what I told you initially in the beginning. What I told you, grounded means what? Grounded means
Our
a common
reference.
point with respect
the
to
lowest
reference,
potential.
with respect to which we measure the voltage. Now this is what the DC voltage is fixed. Now whenever you will apply the alternating signal, the voltage drop will be appearing only across this and this, the output voltage. This because this voltage is remains same. The output voltage, if any change in voltage, output voltage is there, the total change in voltage will be appear only across the VCE, this terminal, only across this and this resistor. Is it clear? For change in AC voltage. So that's why whatever the voltage you are, if you take the reference point with respect to the emitter other terminal here, this is what are the reference point. This is same as the with respect to AC point of view. Taking the reference point with respect to here, this is same as the collector is taking as the reference point because this is common point to AC here. Okay. For alternating, changing thing. That's why this is what the common collector configuration. Okay. That for AC point of view, AC signal as this DC bias voltage remains same, right? This is the power supply, this remains same. So if you apply the alternating signal, if any change in voltage appear in the input, that will lead to the increase the current, and whenever the current will increase, that will lead to increase the voltage drop across what? Voltage drop across the load resistor here, and this change in voltage drop, whatever it is, the equal amount of voltage will be dropped across this, and that will leads to show the what the total voltage remains. This output voltage remains same. Otherwise, as you can see, the total voltage remains same. The output voltage as per the Kirchhoff's voltage law. So if
Sir,
any change in
sir,
voltage happens across load resistance, if it is increased, the same amount it will be decreased.
sir,
Is it
Sir,
small
clear?
confusion. Sir,
Yes.
Sir,
sir,
please.
the diagram which you have drawn on the left, it is grounded and the collector side. So if the same was done at the emitter side, both are the common collector configuration, right, sir? Because
Which
it
one?
depends on the collecting side.
No, no, no. Here, here, this is what? This is collector. This is emitter. This is collector. The whatever the voltage I am taking from the emitter, here also I am taking from the emitter. The voltage drop, if I measure with respect to this, so that measure whatever the voltage, this voltage will be measuring with respect to ground. Also, this voltage will measure with respect to the ground. Okay, the voltage will
This
remain
Okay,
same.
sir.
configuration does not depend on which side we are inputting our voltage. Like here, in these diagrams, one input voltage is VBC and other one is VBE.
Here,
Voltage input. Where we have connected the input voltage. That's why.
the
So
input
configuration
voltage,
depends on that also.
that depends on that also. From AC point of view, actually you are talking about the bias voltage. Okay, bias voltage what remains same. This bias voltage, this suppose there is no AC signal. Here, this part, left side you kept this part. Okay, this bias circuit, are you getting any changes in the bias circuit? If I reverse it, simply the total circuit I am reversing. Are you getting any changes?
No, sir.
So there is no changes physically in the circuit configuration. Okay. So it's basically a common collector configuration. Now in the common collector configuration, what would be this feedback? How it will be? Now if you see here, the what if you see here, without this resistance in the emitter, then if you increase, if any change in input current happens, IB, or if the input voltage changes, then that will lead to change the output current, and that output current will increase output current will increase. So what is the thermal run away? What I wanted to say in the beginning, why the biasing circuit is required, proper biasing circuit is required, or what does it mean by stability? That you will understand from here. So without this resistor, what will happen? Without this feedback resistor, load resistor, RL, just like in this case, in this circuit diagram, to try to understand, if there is a change in base voltage VBE, del VBE is increasing, that del VB increase in del VB will increase the base current IB. Are you getting it? That will increase the collector current IC. Is it clear?
Yes,
Are
sir.
you getting? Okay.
Yes, sir.
So if
Yes, sir.
collector current IC increases, then
Sir, sir, sir,
अरे
common
what
collector, sir, वो grounded, sir, तो zero,
हाँ
grounded, sir, negative potential है, sir.
oh, you don't interfere, you keep in mind, you ask later on, otherwise I can't proceed. If the input voltage is increased, VBE, in any way change in input voltage is increased, then the collector current, for this case, the input current will increase or decrease. Input current will be increased or decreased. Huh? What is this here? VBE means here. This is VBE.
Yes, input voltage.
Input voltage, if it is increased, then the IB will increase or decrease.
Increase, sir.
IC? What is IC? IC equal to?
It also increase, sir.
Beta IB.
It will also increase, beta IB. Then if IC is increased, then what will happen? As per Joule Heat's law, the temperature will increase. Temperature T will increase. So if the temperature increases, that also leads to increase the reverse saturation current, and that will increase the base current effective. Again, that will increase the output current. Again, that will increase the temperature. And so this is a cumulative process. And the temperature will be increased enormously large value. And the transistor may burn out. And this type of effect is known as thermal runaway. Okay. Now, in this circuit diagram, what happens with the connecting this resistor, what happens? If the output current, if we change in input voltage, increases the input current, and due to that the output current is increased, then the voltage drop across this resistor will also increase. And as you can see that this voltage drop across this resistor here, I am not taking across collector. With respect to collector, this voltage will be 180-degree phase shift. But with respect to emitter, this voltage will have same phase shift. For your convenience, that is shown here. Okay. This is with respect to emitter terminal. If you take the voltage, that will have the same polarity. With respect to collector terminal, that will have 180-degree phase shift. So now as it is same phase, so in the input side, overall input now, the overall input voltage VBE is decreased due to the voltage drop across this load resistance, because it will have the same polarity. Okay. So that's why what will happen, it will decrease the output input current as well as the output current. So that is, there is a self correction mechanism that any changes in current or voltage that can be compensated with this circuit mechanism. And this type of feedback, if you see here, the output voltage is taken from here, so V0. Now this V0 is okay. So this output voltage is here, and this output voltage is connected in the input in series because it is decreasing the output voltage, input voltage. So that's why it is a voltage series feedback. Okay. So similarly, the current series feedback in the if you consider a common emitter configuration with load resistance, with resistor in the emitter, common load. Try to understand the difference between the voltage series and current series. For voltage series, we took the voltage across the emitter terminal, and the total voltage is appeared across the load resistance. That's why the total voltage is appeared across the input also. Okay. So the same amount of voltage is appeared across the input. So feedback fraction is here unity. Whereas in the latter case, this again you tell me, this configuration is common emitter or common collector?
Common emitter, sir.
Common emitter with resistor connected to the emitter. Okay, this is called a feedback resistor. Okay, here the load resistance is connected to the collector. So that's why it is a emitter. A resistor is connected to the emitter, and this emitter is grounded to this load resistance. As we are taking the voltage from the collector terminal, output voltage. So it is a common emitter configuration. So now here, look at this. This feedback voltage here, this is what the feedback voltage which is appeared across the input and appear in series with the input. So that's why it is to the input side, it is series. Now the question is the output from the output side, we are sampling whether the output voltage or current. You may ask, it may be voltage because the output is here, which is measured voltage. But here it is the current series. Why? Now look at this here. The voltage drop across this emitter resistors RE. This voltage is VF. This is appeared across this emitter resistor, and this VF is the voltage drop across RE. Okay, so this voltage drop as it is appeared across the emitter resistor RE. Now it is proportional to what? I0 RE. What is this I0? I0 is here, that is the current flowing through I, because IC is almost equal to IE, right? Because IE is equal to IC plus IB. IB is small, and this can be considered as IC. So that's why the feedback voltage is proportional to the output current. So that's why we are here. Here it is the current series feedback type. Similarly, the current shunt feedback type, what we can see, the current shunt feedback type is when the base to a collector to base it is connected. Here the it is we are taking the here the register is connected here, and here it is the current is both at the this side here at the collector point as well as at the input time point. It is divided in two paths, so it is a current shunt feedback type. Okay, so now if you understood this,
Sir,
can you
but
tell
that
me
current part, can you once again explain why current symbol is used there?
here current what I told you? If it takes the two path, when a current takes the two path, then we are taking the current sample, right? Now here look at this. This is a common node. Here two branches is there. So that means if output part of the output current is taking this two path to this register, and now it is connected here to the input, and also in the input you can see it is also appeared in shunt. So with respect to this point, if you see, this is appear across these two parallel. Also with respect to this point, these two paths is appearing parallel. So that what does it indicate? That from the output, a part of the output current is flowing to this base register, and another a part of the input current is also taking this path. So this is what the current shunt feedback type. Now, if you understood this a part of this, can you tell me what type of feedback is this here? What type of feedback is this here? Look at this, the output voltage is taken from here, and this output part of the output voltage, this is taken from through this feedback register, say RF, through this register, and it is appear across this emitter register, say RE, and in series with this. Because here, look at this. Huh?
Some sort of
Okay, so this you think about this also. For this case, what would be the feedback type here? Feedback type. You think about this here, unless taking from the output, it is taking from here and it is connected to the input. So what type of feedback is this? Taking so far with the discussion, you think about this and it is your home task. So just another 5 minutes I will take to discuss about the positive feedback and gain Barkhusen criteria. The overall gain about, okay, before going to that, do you have any queries so far what I told you?
no, sir.
Okay,
Sir,
thank you.
sir,
Current series
sir,
is
did not
not clear.
understand the
Yes, sir. Not able to
Which
understand. Current series and
sir,
current
did
shunt.
not, sir, current shunt and voltage shunt.
current shunt? This one. Why it, first of all, you have to understand what do you mean by current shunt. For current shunt, what we take?
We take current as a feedback from the output and we connect it
Current
in parallel
take the
on the
current
input
as
side.
a sample signal from the output, and shunt means it is connected in shunt in the input, right? That feedback
Yes,
signal. So
Yes,
now
sir.
in this circuit configuration, can you see here? So if this feedback resistance is not connected, what will happen? Then whatever the current IC, that will be flowing only through the resistor RC. Now once this resistance is connected, now a part of this output current IC is taking two paths from here. Look at this, IC is flowing from here. Now it will be somewhat less. This current through this resistor would be IC minus IF if we consider the IF current is flowing to this resistor. So what does it indicates that a part of this collector current is flowing to this resistor. So that indicates that the current sample is taking current is taking from the output as a sample signal. Now here, whenever it is connected, now from this circuit configuration, you tell me it is connected in shunt or series. Now could you understand?
Sir, how we can say that it is connected in shunt? That part, because current is clear that we are giving output
Okay,
current
what is
feedback.
the series configuration? What is series configuration? Now you tell me this resistor is connected in series or shunt?
Series.
R1 and R2.
But in series, the current does not divide. It is the same.
Okay, now in shunt, current is divided, right? So from
Yeah.
that, for if from a common node two resistor or multiple branches appear, that is connected in shunt. That is the simple thing. So now you can see here in the input, what the two, this input is coming actually coming from here. Now if this resistance is not connected, now this input current is input current totally should appear across this. Now as this resistance is connected again, the current is taking two paths. One is along this, another is along this. So what does it indicate? It is shunt or series.
It's a shunt.
Shunt.
So
Channel
now
Yes,
shunt.
now
sir.
could you understand?
Yeah, yes, sir. Sir, can you go back to the voltage shunt feedback, sir, once again?
Current series. Current
Voltage
Yes,
shunt.
sir.
Voltage
Yes,
shunts. Sir, previous.
yes.
Yes. Sir, here also, sir, in output side, a part of it is going back to the input side, the current. A part of current is going into the input side. So then why it is known as then voltage shunt? It should also be like current shunt feedback then.
We are talking about negative feedback.
The-
Yes, sir. Sir, previous slide only. In the voltage shunt feedback, I was asking the question.
This one, na? Here.
Yes,
The
sir. Yes, sir.
previous to this.
This one is no, there is no
No, no,
feedback.
not this one, sir. Slide number 22, I think. Yes, sir. 22 slide.
slide number.
This one and this
Yes,
one
sir.
are same.
Yes, sir. Yeah, okay, sir. Sir, here also in the output side, sir, a part of current is going to the input side. So we are not getting the full output current. So, sir, then why it is named as voltage shunt feedback then? Then that is the same thing which you have discussed then.
So this is the part when we are taking the load resistance across this and from where we are taking the output voltage and input voltage. Again, here look at this, the total voltage is appearing across this. Total, whatever the voltage, say if you see the, if you suppose this voltage is taking, as the emitter is grounded, so we are taking actually the voltage whatever from this. Okay, that voltage totally appearing across this, and the same voltage is appearing, we are taking from here through this feedback resistance, right? So that's why the here the sample is taken as the voltage, and it is
Sir, sorry to interrupt. We have another class. It is already started.
okay. One thing, suppose you have some doubt, so you continue with this. What you will do, you will take another class. You arrange another class. I will intimate say extra class without interrupting your schedule class. Okay, for your convenience.
Okay, sir.
Is it clear?
Okay, sir.
And
Pencil
you
and
go
stop
through.
the recording. So stop the recording, please.
Yes, and you go through all this.
Yes, sir.
So for better understanding,
Sir, download the attendance, sir.
for better understanding,
Are you getting my screen? Anyone?
Yes, sir. Yes, sir.
Okay.
Sir,
Today we are going
differential
to
amplifier.
the question paper. Okay. Midterm question paper. Okay.
विप्लव म्यूट कर ले साउंड आ रहा है.
So the first question is very simple one. Convert binary to decimal. One math. Okay.